Education is the most powerful weapon which you can use to change the world. Good morning, respected dignitaries, distinguished guests and speakers, heads of various departments, all participants who are present here and online, my dear colleagues and student friends. We all have gathered here for the inaugural of 4th International Conference of Emerging Technologies organized by Jain College of Engineering, Belagavi and co-sponsored by IEEE Section Bangalore, which is being held from 26 to 28 May 2023 in a hybrid mode. Jain College of Engineering, situated at Belagavi, was established in the year 2010 under the umbrella of Jain Group of Institutions, headquartered in Bangalore. JCE is recognized by All India Council for Technical Education, New Delhi, approved by Directorate of Technical Education, Karnataka, and is affiliated to Vishweshwara Technological University, Belagavi. 5 undergraduate programs in BE, that is Civil Engineering, Computer Science, Electrical and Electronics Engineering, Electronics and Communication Engineering, as well as Mechanical Engineering, and 3 postgraduate programs, MBA, MCA, and MTech are offered. On behalf of Jain College of Engineering, I welcome you all for the 4th International Conference on Emerging Technologies. It's a tradition at JCE to begin the function with the JGI prayer. Hence, I request all of you to kindly rise for the same.
Om Namo Vajrayana.
another video of insect which will be played by our technical team. So, may I now request all the dignitaries to please occupy their chairs. Where flowers blossom, so does hope. It's time to welcome our guests for today. I now request our Principal and Director, Dr. J. Shivkumar Sir, to welcome the Chief Guest, Dr. S.M. Shivprasad, Director of Higher Education Academy, with the sampling. Thank you, sir. I now request Dr. Krupa Rasne, Convener in SET, to welcome the guest of honor, Dr. Ramakrishnan Raman, IEEE Bangalore Section EXOM Member 2023, Honeywell Aerospace, with the sampling. Thank you, ma'am. I now request Dr. Praveen Chetty, Dean Exam, to welcome our Principal and Director, Dr. J. Shivkumar Sir, with the sampling. Thank you, sir. I now request Dr. Vidya Dandi, ma'am, HOD MCA, to welcome Dr. Krupa Rasne, ma'am, Convener in SET, with the sampling. Thank you, ma'am. I now request Dr. Hubali, sir, HOD Mechanical Department, to welcome Dr. Sunil Soumya, Assistant Professor, Triple IT Dharwad, and our keynote speaker for today. Thank you, sir. I now request Dr. Rajshekhar Gowda Patil, sir, to welcome Mr. Harish Patil, Partner INSEC, with a bouquet. Thank you, sir. May I now request all the dignitaries on the dais to come forward and light the lamp. Thank you, everyone. I now request our Principal and Director, Dr. J. Shivkumar, sir, to brief us about the conference.
Pleasant morning to all of you who joined both offline and online for this inaugural function of 4th International Conference of Emerging Technologies, INSET 23. I, on behalf of Jain Group of Institutions, Jain College of Engineering, feel immensely happy to propose welcome address for this inaugural program. I welcome Dr. Shiv Prasad, Director of Higher Education Academy, Dharwad, and Professor at Jawaharlal Nehru Center for Advanced Scientific Research, Bengaluru, who has honored us by his presence as chief guest of this program. I welcome you, sir. I heartily welcome Dr. Ramakrishnan Raman, IEEE Bengaluru Section Execom Member 2023 from Honeywell Aerospace India Limited, Bengaluru, who has accepted our invitation to be the guest of honor for this inaugural program. I welcome you, sir. In fact, Dr. Ramakrishnan Raman is delivering the keynote address after the formal inaugural program. And I would like to welcome President of today's program, Professor R.J. Dharwadkar, sir, Senior Director, Jain Group of Institutions, in his absence. So he has expressed his inability due to unavoidable circumstances. He is not present in today's program. However, he has sent us greetings and wish this inaugural program as well as the conference a grand success. I welcome Dr. Sunil Soumya, IIIT Dharwad, who has invited as invited speaker. I welcome you. I welcome Dr. Kruparasan, convener of this conference. So he has done a lot of work from last 15 days. He is into this, and I welcome her. I extend a warm welcome to all the resource persons for the invited talks and session chairs and the session coordinators, as well as delegates and the paper presenters and invitees. And I welcome representatives from media, both the print as well as paper. And I welcome representatives of IEEE section. They are the technical sponsors of this program. And as far as INSET 2023 is concerned, this is fourth time in a row we are conducting this international conference of emerging technologies. We started from 2020. So INSET 2020, 21, 22, 23. This is the fourth international conference that is being arranged from the Department of Electrical and Electronics Engineering of JCE, technically association with IEEE Bangalore section. And the goal of this conference is to bring together, of course, researchers both from academia as well as industry, as well as practitioners to share ideas, problems, and solutions of the emerging technology. The conference will cover the multifaceted aspects of computing technologies, computer systems organization, information technology and systems, and computer applications. And the researchers were invited to submit papers to this INSET 2023 that addresses issues that serve present and future development of the field. So I am very glad to inform you all that we have received total of 1765 papers. 1765 papers were received by the researchers all over the globe. And we accepted. And there is a thorough review mechanism. And only 390 papers were accepted with the acceptance ratio of 26%. About 23 countries participants have participated, including Japan, Malaysia, UK, China, etc. The total papers have been reviewed by 156 reviewers. And there are total 58 tracks, including both physical and online mode, with 46 session chairs attending the same. And all accepted papers, 390 papers, will be published in the IEEE Explore. And all our earlier conference have already been published in IEEE Explore. I am happy to share with you that in last 4 IEEE conferences, like INSET 2020, 21, 22, 23, up to 22, almost 100 papers, 1,000 papers have been published in the IEEE Explore. And I'm very happy that tomorrow, one more invited speaker in the form of Dr. Yang Yu, School of Information and Communication Engineering, Jain Tech University, Xi'an, China, is also attending this conference online. So he is addressing us with his invited talk. So tomorrow he is addressing. So on behalf of the institute and on behalf of the IEEE, I extend a warm welcome to him also. To conclude, I wish this conference a grand success. This is a 3 days conference, international conference. So organizers have arranged meticulously their plan, and you just enjoy this conference. I wish this program a grand success. Thank you.
Thank you, sir, for providing us the insights about the conference. Now we have the release of conference proceedings. May I request all the dignitaries on the dais to please do the reading. Thank you, sir. May I now request Dr. H.P. Rajni ma'am to introduce our guest of honor, Dr. Ramakrishnan Raman. I wish a very pleasant morning to all the dignitaries on the dais, off the dais, and the respected audience. It's indeed a matter of great pride and privilege for we, the organizers of INSET 2K23, to have eminent researchers and accomplished academicians as our guests. It's my pleasure to introduce our distinguished guest of honor, Dr. Ramakrishnan Raman, to you all. Dr. Ramakrishnan Raman is a reputed technology leader who drives strategic cutting-edge technologies across multiple sectors of excellence. He has significant global experience in applying thought leadership on engineering and strategic operational dimensions and is a certified Six Sigma Black Belt. He is a proud alumnus of IIT Madras for BTech and MS degrees, and Sir has obtained his PhD from prestigious IIIT Bengaluru. He is currently fellow at Honeywell Aerospace. He is an INCOS certified expert systems engineering professional (ESEP), an IEEE distinguished lecturer and fellow ISSE. He has over 25 years of extensive experience in systems and software engineering. He has to his credit several publications and has best paper awards in referred in the international conferences and journals on complex systems architecture design, artificial intelligence, and machine learning. He is also active in the professional societies including IEEE, INCOS, and SAE. He currently co-chairs the INCOS AI Systems Working Group, and he is also the chair of IEEE Bengaluru Section Systems Council Chapter. Dr. Raman has received many organizational awards, including 2010 Honeywell Technology Solutions Annual Leadership Excellence Award. In the year 2016, he received the Outstanding Service Award from International Council on Systems Engineering at Edinburgh, Scotland. He has also been the technical program chair for international conferences, including 2016 and 2019 Asia Oceania Systems Engineering Conference, 2022 SAE Aerocon Conference, and the 31st INCOS International Symposium. Dr. Ramakrishnan Raman, though he is at the top leadership, he is an ardent academician at heart, being inspired by his father, who was a former professor in mechanical engineering at IIT Chennai campus. And he is an ardent academician till today, and he is involved with many academic institutions and has been the guest faculty at IIT Bombay Aerospace Department and adjunct faculty in Manipal Institute of Technology. He is an excellent culmination of academic brilliance, research mindset, and extinguished leadership qualities to create marvels in engineering and technology. It's indeed our honor to have such a distinguished personality as our guest of honor, and thank you, sir, for accepting our invitation, and we look forward to fruitful interaction with you in the coming days. And thank you all. Thank you. Thank you, ma'am. May I now request Dr. Ramakrishnan Raman, sir, to please address the guest.
Honorable dignitaries on stage, the chair of the conference, Dr. Jain, Chief Guest, sir, Dr. Shiva Prasad, Director of Karnataka Higher Education, and Professor Kubha, who's chairing this conference through. It is indeed my honor and privilege to be invited for this inaugural session of this fourth international conference on emerging technologies. So this conference being organized by the Jain College of Engineering Research, Belagavi. I've seen that it has been established itself for the last 4 years as a well-recognized forum for researchers to come together to share their knowledge and advance their technical knowledge through exchanging of their ideas. So such an international conference, I've been involved with many such conferences. It provides immense benefits for both industries and academicians, right? Because that's where you have the meeting of the minds. The paper publications, the peer-reviewed papers, those are the core part of the conference. That's where we are seeing a lot of brains coming together to share their ideas and that kind of generates the knowledge through. Right? So I would first of all congratulate all the authors of those 390 plus papers. I mean, it's a phenomenal amount to even manage this 1,700 plus submissions, getting all of them reviewed over a definite amount of time. It's shortlisting 26%. That's a very good, which means only the top 25 to 26% of the papers get selected. So you can actually be assured of these are the cream of the papers too. So in fact, I was going through IEEE Explore for the past proceedings of this conference through, as I mentioned, it's over 1,000 papers. I'm sure all of you have access to IEEE Explore. You could go through that and see, and it covers a broad range of topics too. And that's, I'd like to once again congratulate all the authors. So I'll just take this opportunity to briefly share some of my learnings over this industry. Right? Like, if you see a lot of systems, right, they are becoming more and more complex over a large period of time. Right, they have been evolving through. Right? And increasingly, we try to put more and more functionality into a system, more and more intelligence into a system, make it more intelligent, make it more autonomous. The basic functionality of a phone, right? What is it? It is to make phone calls, right? But none of us go to a shop and say, I want a mobile phone to make phone calls, right? I mean, I'm sure your students, you all look at how much megapixel camera it has, how much of GBs of storage it has, and all of those kind of things, right? So you can actually see how the mobile phone has kind of evolved to becoming an encompassing device. Like for instance, most of you, I'm sure, young crowd, you take a lot of pictures, right? A lot of photos with your mobile phone. Those days, if you want to take a picture, we actually dress up for the picture. I mean, some of you might laugh for it, but yeah, we dress up. We used to buy a film roll, right? Once I take a picture, I can't share it with my friends. I have to wait till 32 such pictures are clicked. Right? And then it'll take a couple of months, obviously, and then we can't still see it. We have to go to a studio where we get it developed over 4 or 5 days, and then we get prints of that. We put it in an album, and then we show it to our friends. So our basic purpose of capturing a photo is to share it with our friends. Right? Now, what do? I'm sure all youngsters, you click a picture and post it on your Facebook or Instagram or whatever. You will get the same benefit, right? Your benefit of sharing your picture with your friends. Now you are able to get it in a shorter period of time than we used to take months or days. Right? So as these kind of advances in technology keep happening, we'll see the paradigm shifts that are happening today. So that's where as a young students, we'll often get enamored by technology. In fact, just before this inauguration function, we were having a good discussion with the chief guest in terms of how ChatGPT is now changing the way things are happening. Right? I'm sure as students, you will be relying a lot more on ChatGPT, right, to get what those concepts are, what those things are. So definitely those kind of technological advances helps us because we start moving out to the next thing, the next point in time. Right? And obviously any of these technology advances, you will see like, hey, this is going to take away jobs. This is going to make my job redundant. Right? The example I say is when calculators came, they didn't take away the job of accountants. Right? You still have a lot more complex things to do. Right? So, as students, young students and academicians, who want to pursue in the research field, keeping abreast of the technology, right? Seeing in what it matters for us, and how do you leverage that. Right? So, one thing I often stress is the system thinking and big picture. Right? How do you look at the big picture, and how do you, in fact, ask the right questions? Right? Typically, as Indians, given a question, we always try to figure out what the answer is. Right? We can always figure out, but then coming up with the right question, right? That is often a challenge. Right? So one example, I'd like to quote. There was this particular incident where one of the car manufacturers, right? They got a call from a customer who said, when I take my car to the ice cream shop and whenever I buy, vanilla ice cream, the car doesn't start. And when I buy these kind of set of flavors, these sundaes and all, my car starts. Right? That is a problem. Right? So that's the problem that he got a call, that the customer center got a call, and they asked an engineer, right, to figure out what is this. Why is the car allergic to vanilla ice creams or some other chocolate ice creams or things like that? Right? So, the first thing that engineer did was to sit with the customer and observe all that he did. Right? Because obviously the question is not why is the car allergic to vanilla ice cream. Right? So he started observing and all of that, and then he found out that okay, that was I think a cold country, and vanilla ice creams were available near the billing counter. Right? Which means like it's straightforward, right? Plain vanilla. You can go to the near the billing counter, pick up the ice cream, and come back, right? Easily. Whereas when you want the special flavored ice cream, so you have to go to the back of the store, right? And then order it. It takes some time to prepare, and then he comes out. Right? So now, if you start looking at okay, what does it translate to? Right? The time between when he stops the car and tries to restart again, it is very short for vanilla ice cream. Right? Whereas it takes 15-20 minutes if you want other flavor of ice cream. Right? So now what is the right question? The right question is why does the car doesn't start when after a shorter interval, but it starts after a longer interval after stopping. Right? Once I stop it, if he starts in 5 minutes, it doesn't start. That's when he bought vanilla ice cream. And if he starts in 15 minutes when he went for that flavor of ice cream, it starts. So now that's the right question to ask. What is the duration? Right? It took through. Right? So what he figured out was there is a vapor interlocking, right, in the car, which prevented it from drying and cooling down. The cooling period was longer, right, when he bought other flavors ice cream. So that's the right question to ask. Right? So often as researchers, we would struggle with what is the right question. I'm investigating the right problem. Right? Otherwise, we would easily get diverted and spend a lot of time in trying to figure out what is the wrong question. Right? If you don't get that question right. So that's where an aptitude of science, engineering, maths, system thinking helps. A lot of times most of the information is in your fingertips. Those days when I was doing research, if I had to find out or read a paper, we have to go to the library, take it from a book, a bound book, and xerox the papers that we want. Right? These days at your mobile phone or in a laptop, you can easily access it. But then, are you leveraging that kind of information to make better decisions? Is what you will have to see. Right? So I'm sure as young students, you have a lot more information to explore, but then try to use it to ask the right questions. Right? How does this matter? What is the right question to ask? Use that as a means to further, your understanding of this. And of course, AIML. I mean, my talk is also going to be on AIML later. It is kind of changing the landscape. Right? And how ready are you for the technology? How ready are you to look ahead for the technology? I mean, this is a conference on emerging technologies. When I look at the papers that are published in this conference, will give you a broad idea of all the various research that is happening on these emerging technologies. So, I encourage all of the researchers, the students, to look at that and ask the right questions, right, and go in the right direction. So, with that, I would like this. Thanks to the organizers once more for inviting me for this conference. And I'd like to once again congratulate the conference organizers and the committees to, in fact, successfully conduct the fourth edition of this conference, which is really a wonderful feat by itself too. And I wish this conference a grand success. Thank you.
Thank you, sir, for sharing your experiences and also stressing on the importance of asking the right questions. Thank you, sir. May I now request Dr. Salma Shapurkar to introduce our chief guest for today, that is Dr. S.M. Shiv Prasad.
Good morning to everyone. It gives me immense pleasure to introduce today's chief guest, Professor S.M. Shiv Prasad sir. Shiv Prasad sir is a Director of Higher Education Academy and Professor at Jawaharlal Nehru Center for Advanced Scientific Research in India. He has PhD in Thin Film Physics from Karnataka University, Dharwad, followed by post PhD in Thin Film Physics from Karnataka University, Dharwad. Sir is scientist at National Physical Laboratory, New Delhi, for 2 decades before he joined GNCASR. He is a visiting scientist at National Institute of Standards and Technology, at Rutgers University, USA, Tohoku University, Japan, and University of Ulm in Germany. He received the Young Scientist Award from the President of India and Raja Raman Senior Scientist Award from Government of Karnataka. He has been awarded the Medal Lecture, Superconductivity and Material Science Awards and Distinguished Leadership Medal by Material Research Society of India. His research interests are thin film, surfaces and interfaces of materials and semiconductors, growth and properties of nanostructured wide band gap semiconductors. Sir has published 296 research articles in international journals and 28 articles in national journals. He has authored 2 books and edited 1. He is the Indian representative to the International Union of Vacuum Science Technology Applications World Material Research Institution Forum, Europe-India Cooperation for Nanotechnology and Indo-Brazil Cooperation for Science. He is the Vice President for the Materials Research Society of India. He has recently become a member of Vision Group of Science and Technology of Government of Karnataka and on the advisory board of BEL for Night Vision Device Development and DRDO for Smart Material Research. He is on the board of management of SDM Medical University Dharwad and visiting professor at KLE Tech University Hubli. He is also an accomplished cricket player, played Sussex Company and DDCA Brigade. He represented his schools, colleges of Karnataka, Sussex universities in cricket and table tennis. Welcome you.
Thank you, ma'am. May I now request our Chief Guest, Dr. S.M. Shivaprasad, sir, to address the gathering.
ನನಗೂ ಕಾಪಿ ಹೊಡೆದು ನೋಡಿ ಸ್ವಲ್ಪ ಪೇಪರ್ ಹೊರಗೆ ತೆಗ್ತೀನಿ. Okay. Good morning to everybody. It's a delight to be in this august gathering. Thank you, sir, for inviting me to spend some time with these beautiful youngsters I see around. I love the campus, the way it is structured, and this is my first visit to this campus, and I'm sure there are very nice things happening on this campus. Let me start with a story. There was a woodcutter, a poor woodcutter with an iron axe. He used to go every day, cut the wood, take it and sell in the market, and make some living, a very, very modest living. And one day he was cutting the wood, and you know the axe fell down into the lake which was beneath. You all know the story. Yeah, it fell into this. Then he was so sad because he didn't have his main weapon or instrument. So he came down, started crying in front of the lake, and started crying that he prayed God that please help me. Then God was sleeping early in the morning, got up and he said, "Okay, boss, what's your problem?" So he told me I had only 1 axe. It fell into the water. Now I have a livelihood problem. So please help me. So God wanted to test if this guy was honest. So he went out and took an axe, right? He brought a golden axe and he asked, "Is this yours?" He said, "No, no." He was very honest. He said, "No." Then he brought a silver axe. He said, "No." Then he brought that old broken iron axe. And this guy said, "Yeah, this is it. This is my axe." So God was so impressed with his honesty. And he said, "You are so honest that I'll give all the 3 of you." He took all the 3, went home, and he explained what happened to his wife. So his wife was also very impressed that, my God, it's an amazing thing. It's a miracle. Let me also come and pay my respects to that God. So they both came, walked along. He was explaining the story. I was here, the eggs fell down, etc. And this is the lake edge. And she slipped and fell down into the water. Now he was worried, right? He was worried. And he started praying again. Right? He was again prayed to the God, and he said, at that time, God was having his afternoon siesta. He was sleeping. Again, he got disturbed. And then he came out again and he said, "What's your problem again in the afternoon? Okay, you got all the 3 eggs, the golden eggs, but still why are you back?" Then he explained, no, my wife has fallen down. I had only 1 wife. So please help me. Okay. So God, okay, said, "I'll help you, but let me try to see if you're honest."
right? So again, he brought Aishwarya, right? And this guy said, yeah, she is my wife. So that got very angry, right? Morning you are honest, and afternoon you are a terrible guy. What happened? Why? You said you are an honest poor guy. He said, I'm still an honest poor guy, and that's why I made this choice. Because I'll bring Aishwarya Rai, and I'll say no. Then you will bring Katrina Kaif. Then again I'll say no. And then you will bring my wife. And then I'll say yes. Then you say, you are so honest, take all the three of them. And I cannot manage all of them. Right? So, you see, what I wanted to tell you is bring this context of materials and how honest we are with our work. This is very, very important for us to realize, because you look at the story of human civilization, right? It's gone from the Stone Age to the Bronze Age to the ceramic age to the semiconductor age to the plastic age, and now a lot of garbage. And it's all come because of technology, right? It's all. But you see, the length of the spans of these technologies were thousands of years earlier. There were 2,000, 3,000 years for the Stone Age, nearly 1,500 years for the ceramic age. Like that, it went on changing. And now the size of the technologies is extremely small. They live for a very short period of time. It's very important for us to be aware of these changes. But again, as we are all aware, three amazing technologies have come together, which has never happened in the past: the nanotechnology, the biotechnology, and the artificial intelligence. And these are going to revolutionize the way we look at this world. In the next 5-10 years, I don't think we are going to see the world we see it today. It's as Dr. Raman said, a big change is in the offing, right? And are we ready for this? The word used was, are we ready for this change? And that, I think, is very important. We were discussing in the one, as he mentioned, we were discussing in the room there, what are the changes? One, for example, we know that there is cryptocurrency now, right? We use bitcoins. India also has a digital rupiah now, right? So that means in 10 years, the transactions will take place through the blockchain technology. We don't need banks anymore. So there will be no banks 10 years from now. Think about it, right? There will be no banks in this world 10 years from now. Now, in China, they're using 17% of their court cases are solved by artificial intelligence. There are no lawyers, there are no judges. And India, in this year's budget also, we have included money for that, because we also want to bring AI into the judiciary. So think about it, maybe 10 years from now, no lawyers, no judges, right? Or very few of them, but most of them will not be there. Madam was also mentioning 5G is there. When there is a 5G, okay, you may get holographic images of teachers inside your classroom. A professor in Harvard will come with all his knowledge, with all his animations, with all his technology, and walk around in your classroom. Okay, right? He walk around in your classroom and teach with all his in your language. He will speak there in Harvard in his language, and you will hear it in your Belagavi Kannada. Right? Such transformations. So if there is amazing professor from Harvard who can teach the whole world, and when will he teach you? Whenever you want him to teach you. Right? How many times will he teach you? As many times as you want to listen, teach you. Right? Think about this change. Right? Now, if this is going to happen, what is going to happen to education? Will teachers become an extinct species sitting with the dinosaurs? We need to think about this very clearly. Also, we had talked about clones. Already there were clones. Okay, clones were found, but we stopped it because we didn't want it to come into human cloning, etc. So it was banned. But basically, it's happening. You know that it's not happening. Now there is something called as the digital clones which are being made, what is called as digital analogs of people. So what they do is they completely put all the information you require about me into a computer, and there is a digital clone of Shiva Prasad in the computer. So when the doctors want to do anything, either give a medicine or want to do a surgery, it does it on the digital clone, sees the reactions, etc., studies it properly, and then does it on Shiva Prasad. And how he will do it, this right now it is being done by the doctors. We also recently saw an operation done from San Diego in Manipal Hospital in Bangalore. Our doctors were standing around and watching, and the doctor doing the surgery from there on the internet. So, and soon, now we have with digital cloning and this internet surgery, the whole surgery will be done by machines. There will be no doctors anymore. Think about it. 10 years from now. Now, ChatGPT. You all know the power. It's just very, very young. It's just born. It's created such a revolution. What a revolution. Amazing for students right now. All your homework, everything comes with ChatGPT. And he was also mentioning about people writing research papers using ChatGPT. I also asked the ChatGPT to write a poem on Dharwad, and it wrote a poem which was better than many of the poets in Dharwad. Okay, such a beautiful poem. So if it can do something like this, if AI can do something like this, what will happen to all of us? What will happen to education? What will happen to our life? What will happen to our industry? And look, another thing, we talked about the farm laws, you remember. Farm laws is private cooperatives. Huge private cooperatives where the tiny, tiny lands are occupied by the private, use huge machines and do the agriculture. And the farmers have no job. Farmers will lose job. The last one I'll give you example. This is a research paper published in the journal Science in 2019, July issue of the Journal of Science, one of the best in America in science. It is done by a paper in collaboration with the MIT and Cambridge University. Professor Cordio and Wood have collaborated and they have written a paper. That paper, I don't want to go to the details of the paper, please go and see. Just I'll tell you the title of the paper. The title of the paper says, Death of Death by the year 2045. This is not science fiction. It is not Steven Spielberg's movie. Right? It is real science. Now we have understood what is aging and death. And we see that now aging and death as a disease. We don't see it as an inevitability of being born. Think about it. Very interesting. So, my young friends, I may not be alive in 2045. All of you will be alive in 2045. So you can celebrate your 200th birthday, maybe get married when you are 500, no hurry, and have children when you're 800. Enjoy your life. Things will change a lot. Let me tell you, in the next 4 or 5 years, the average age of existence of mankind will reach 150 unless we decide ourselves to kill each other. Right? Very important to understand. Now we need to rethink about everything about our life. Right? The kind of jobs which are going. We said, there is always this fear when technology came. Will it replace the jobs? Will it give us opportunities? But we have always found out conventional jobs will go, new jobs will come. Right? This is the emerging trend of technology. And this is going to influence, as I told you, not only the technology field, but also writing poetry. Everything in this world is going to depend on these kind of changes. So, should we read? So, let me tell you another story. Right? There was a cap seller. Who used to go from one place to another selling caps. He would carry about 100 caps, go from one place to another in the hot sun. And he was walking and he took rest under a tree. And when he got up, he saw there was only one cap on his head and the other caps were missing. And he didn't know. Shivkumar sir was walking around. He asked him, Sir, I don't know where my caps have gone. He said, Hey, look up there. And he looked up and he saw those 99 monkeys wearing his caps on the tree. Then he said, Sir, what shall I do now? So Shivkumar sir said, again, it's very simple. They are monkeys here. Understand them. They'll imitate what you do. Then he got the idea. Then he said, okay. He said like this, and the monkeys also waved at him. Then he took his cap up and down, up and down. They also took the cap up and down, etc. And then he said, ha ha ha. How did you do it? Can you show me? Okay, how ha ha ha? Yeah. Okay, I knew you'd do it. Okay. And then he took his cap up and threw it down. And all the monkeys threw it down. He collected the cap. He kept it, went on his business, very happy. His grandson also became a cap seller. Right? Grandson also became a cap seller and he was doing the same thing. Now he had 100 caps. He was resting under the tree. He got up and saw only one cap in his head and no caps. He did not want Shiv Kumar sir because he knew his grandfather had told him. So he directly looked up and saw all the monkeys there. Right? Then he waved his hand. Okay, they also waved his hand and it would ha ha ha. How did you do it? No, I'm sure you won't do it now. Okay, right? And he did that. Then he took his cap up and down, and they also did it. And he threw it down. And they all together shouted, "We also had a grandfather." Right? You understand? So, friends, this is very important. Our knowledge, what our grandfathers gave, or our fathers gave, or our teachers gave, or what we read, is not going to be useful anymore. We have to keep in change with the emerging technologies which are happening. About the knowledge, we need to gain the knowledge which is necessary. The awareness of what's happening in this world is terribly, terribly important. That's what we are talking. We need to change the syllabus every 6 months now. It's not even 4 years or 1 year. It's going to be 6 months. Look at the faces of the teachers. They're already shocked. That's the challenges of teaching become enormous. Otherwise, teaching, education will lose its relevance. The information is all available all over the world. As I said, we used to go to the libraries. Now there is no need. Now we go to the library only to see a beautiful girl. Like otherwise, we don't go to the library anymore. So you have this whole change of the paradigm again, and how we need to interact and adjust to the changing environment is terribly, terribly important. So now I have to have an education which is beyond GPT. GPT is a useful tool. It's like your calculator now. All the information you want, you get it. Now, what do I do using this information? Our education system, as we were talking, is about remembering things. Right? Now, remembering is not necessary in this future world. Somebody will remember for you. Somebody will give it to you on the mobile. Somebody will give it everywhere. So, what is the point in remembering? Right? I have spent maybe 4 or 5 years of my life remembering Arundlaru, Arundadu, Kannadu, Arundadu, right? We spent so much of our life unnecessary wasting time because there were no calculators at that time. Now that there are calculators, we don't need to do all this business, right? So now, how do we modify the education? So a couple of small suggestions with my interest. Beautiful story about this. Behind all this is the word research. If at all we want to do, even as undergraduates, first year, second year, whatever you do, you have to learn what is research. And you have to start doing research. Research will be the future. There is no education in the future, but research will be the future of education. So how do we implement research in our curriculum? How do we do it in my activity? How do we do everything is the challenge. Let me tell you a small story of somebody called as, I don't know that. There's an 18-year-old boy. 18-year-old boy, very bad in school, not successful. His father comes and asks the teacher, again, he comes and asks him, "Sir, what do you think my son will do in the future?" Shukmar said, "This guy, if he does anything in life, I'll be very happy. He is incapable of doing anything, neither good nor bad." When he was 18 years old. At 28 years, this boy writes 3 research papers. Theory of relativity, photoelectric effect, and Brownian motion, 1905. 3 amazing papers which transformed the way we looked at science and all. And he became the greatest scientist ever in the history of mankind, Albert Einstein. Boy was 18 years a bad student. How did he become the greatest researcher in the world? So Einstein answers it very beautifully, which I want to share with you, which defines what should be the education of the future. He said, "I was a fish and my school wanted me to climb a tree. I was a fish and the school wanted me to climb a tree, and I tried very hard to climb the tree and I suffocated." Right? Because all others could do. I could not do it. So I felt very stupid. I thought I was incompetent. I was stupid. I'm good for nothing. I felt like that. And so look at the kind of education we give. Right? We all want them to climb the tree. The same curriculum, the same syllabus, the same examination. If you do well, you are smart. Otherwise, you are useless. This will change. And then he goes on to say, the teacher told me one sentence. I used to get 10 questions in my head. So when I got busy thinking about my own questions and forgot what the teacher was teaching in the class. So I lost connection with the teacher. So I couldn't understand inside the classroom. I went home to study. Then also I got 100 questions now in my head. Okay. So I was very unsuccessful in my examinations in this. So I was only asked to prepare answers to the questions which the teacher asked, whether it's in the classroom or in the test or in the examination. I had no opportunity to ask my own questions and find answers to them. He says, after my education, after completing education, I had the opportunity to ask my own questions and find my own answers so I could contribute something to knowledge. That will be the kind of education we are going to see from now on. People who are going to miss this bus are going to again remain as slaves of a technological world. That is very, very important. We very easily talk about saying we want to become Vishwaguru, we want to become world number one, etc. Unless we change what we are doing, this is not going to happen. And these changes are going to happen very, very fast. I told you, 10 years from now, 15 years from now, the world we see will not be what it is today because of these three amazing technologies: nanotechnology, biotechnology, and artificial intelligence. So now, and they're so multidisciplinary, you can't have silos and say, I'm only a nanotechnologist or a biotechnologist or an artificial intelligence guy. Now it's going to be completely multidisciplinary. Multidisciplinary, interdisciplinary, interdisciplinary. So how do we bring that into our education? How do we bring it in the way we study? How do we bring it is the challenge which should happen immediately. And this is the time such conferences should discuss that. It's not about just coming, reading a paper, getting your marks, putting it showing for your promotion, for your PhD, etc. All that will not make sense in 5 years from now. Nobody will ask you for your PhD. They'll just ask you for your skill and your ability. Do you have that particular skill and ability? So start thinking differently from today. It's not difficult. We all have the hardware which is necessary. We have the 80 billion neurons, okay, which are capable of making connections. We have the same hardware which Einstein had. We have the same hardware as Madame Curie. Right? It is the question of education is the one which uploads your hardware with the kind of software. It is the kind of software we load into our head which ultimately makes us use the hardware. And that is in your hands. And that is what is very, very important. So, it is not only about domain knowledge anymore. It is thinking beyond. I keep telling our students should not become alcoholics. They should not even become workaholics. They should become thinkaholics. How do we think? And everything you do, how do I think is very important. He asked about one question about the vanilla. I'll give you another small example. Right? There is a bear, karadi, bear, which is thrown for about 100 meters. It takes about 2 seconds to fall to the ground. Okay, what is the color of the bear? What is the color of the bear? You think about it, it's not difficult. Right? You calculate G. If the value of G is 9.8, it is on the equator. If it is 10, it is at the polar, and this happens to be 10, the polar bear is white. Right? Now, we need to relate many fields together now to think in the future. We need to relate many fields. Otherwise, just being silos, remaining in silos, is not going to help us or our nation or this humanity any ability. So another important thing is to understand what I call as graphs and equations. This, I think, is the key for education. So if I give you a graph of any shape, you should be able to write an equation for it. If I give you an equation, you should be able to draw a graph for that. Like, I tried a small experiment during the corona with some students in Karnataka College in Dharwad online. What I did was, on the first day, after making them feel comfortable, I told them, now you're sitting in the house. You change something, something else changes. Plot a graph of this and bring me in 1 week. They couldn't understand the question because they're all students of BSc in physics. And they couldn't understand the question because we have not made them to think at all in our life, in our education system. So I said, I'm not going to give you any answers. You think on your own. They went on calling me. Some students called me at 2 o'clock in the night. Sir, I'm not able to get sleep. What is this question about? I loved their enthusiasm to do that. But I said, I'm not going to give you the answer. You think and anything you change, something else you change, which is happening in your house. Okay. And 1 week from now, they gave amazing, amazing graphs. I couldn't believe it, and I wouldn't have thought about that. So I won't go into that large story because it's a very beautiful story, some other opportunity. And they came up with some graphs. One example I'll give you, somebody just took a popped corn, put it in the microwave every 5 seconds. Okay, you would put a different corn and measure the diameter of that pop. And he plotted a graph and it popped. What happened to the graph? Somebody else took leaves from different size of a branch in the house, okay, from old leaves to young leaves, and measured the diameter to the length of that and plotted a beautiful graph, which is very revealing. Then I told them, look, there are so many functions. There is y is equal to x square, which looks like this. Y is equal to x cubed, it looks like this. Y is equal to x cubed looks like this, right? All these, e raised to x looks like this. Okay, log x looks like this. About 10 functions. And that's all there are, about 10 functions in this whole world matrix. Okay. So what do I do with these functions? I told them, now look at these functions and tell me which graph of yours which function. Right? Which function? They said, sir, it looks like that, but it doesn't fit that. That was the next week. It looks like that. Somebody said, sir, half looks like this function and half looks like this function. I said, now let's start fitting that. Now let's put the coefficients for this. Y is equal to x square. What are the different coefficients I can put for it? We never give importance to the coefficients. You all remember? Yeah, we think that is not important. And coefficients are the one which actually brings the shape into practical reality. So go on changing the coefficients and see which one fits. Right? And they were able to come to an amazing job. This is nothing but research. What is research? Again, it's a very, very long, interesting story, but I'm just cutting it short. I just want to tell you this is research. Make an observation. Plot a graph. Find it everywhere. Find a commonality. Find a trend. Plot a graph. Put an equation. That becomes your law. That becomes your principle. So can we do this rediscovery of knowledge in our education systems? Can we create such an atmosphere that the students are actually sitting there and recreating that knowledge just like what Newton, Einstein, or anybody did? It's something very, very important to make us think. That, I think, is very, very important. Another thing is, we need to now technology has gone so much ahead that we cannot do it alone. We have to have partners. Nobody can become an expert all in nanotechnology, biotechnology, and artificial intelligence. But I need to find the biotechnologist, nanotechnologist, and the AI guy and sit together and work. But working together is one of the most difficult things in India. You know that? Right? Ask the teachers, they'll tell you. Especially during NAC or NIRF or anything like that. Look how many fights happen in our companies, right? Very, very difficult to work together. We're all good as individuals, right? We don't know how to work together. So I'll tell you another last story, and then probably finish here. Every year there is an Olympics which is held in the forest. Every time they try to find out who is the Usain Bolt in the Olympics. So every time it is the rabbit which wins the race. And there is that fellow called Tortoise who never tries, he never goes for the race because he thinks it's not possible. But again, one day he meets Shukmar sir. He is motivated. He says, come on, yeah, go and try. Maybe something can happen. He motivated him. So ultimately, this guy, this tortoise, went for the race one day. And he ran, and you know that the rabbit ran very fast and saw that this fellow is still there. So he slept beneath the tree, and this fellow went across. The tortoise won the race. And the moral of the story in the forest was, slow and steady wins the race. Then they put a big banner saying slow and steady wins the race as a motivation for youngsters. But Now the rabbit started thinking, hey, why did I lose? I was such a great runner. Why did I lose? I just made a mistake of sleeping. Otherwise, I would have won very easily. So he learned from his mistake. And then he again, next time when they ran the race, the tortoise was ready to run this because he knew that this was a lazy guy who will sleep again. But this time, the rabbit corrected his mistake, ran and won the race. So immediately the banner was changed to fast and steady wins the race. So modern world is about fast and steady. You cannot be slow and steady anymore, right? Fast and steady. And then this tortoise, they called him to inaugurate a conference, made him the chief guest, cut the ribbon for 1 year, right? So he enjoyed that importance. Now suddenly again the rabbit started getting back. So this fellow felt very sad. Then he went to Shukmar sir again and said, sir, what shall I do now? Then he said, hey, think man, think. So this fellow started thinking. Then he came to the rabbit one day and told him, hey, I want to run a race with you again. So this time the rabbit said, oh, no problem. Now I've learned from my mistake, right? I know fast and steady wins the race. I'll run the mistake anytime, anywhere, any place. He says. Okay. So now the rabbit said, and now the tortoise said, okay, this time the race will be in water. Because he said any place, right? So he said in water. So obviously, then both of them realized, both of them signed an MOU together. When the race is in water, you will go. When the race is in land, I will go. Both of us, let's win all the medals. And that is the secret of success, and which is absolutely essential in the future. Friends, let me tell you, if, when you look at the sky in the night, we see about 5,000 stars. We can see by bare eyes. But actually, scientists have found out 2.2 billion stars. Among these 2.2 billion stars, we have nearly seen about 7,000 exoplanets, which are similar to the Earth. Okay, but none of them have water, which we know right now. Only this wonderful place called water, okay, the land, the atmosphere, the water, and the sunlight have come into such great combination that we have produced life. It's the only place among the 2.2 billion stars that we know has life. And we have 94 lakh species of life. We have identified 94 lakh species. Among that, the most evolved is you and me. Isn't it such a pride that we are alive? Just being alive is a matter of pride. Among that, you are the most educated people working in technology, in science and technology. Such a pride just being there. So feel proud. Even if you die doing nothing, you have already achieved so much in life. Right? But if there's an opportunity, we are the most evolved, but we now need to behave like one. We have to behave like evolved species. I cannot behave like a dog or other animals which are not yet evolved. I don't blame them. It's not their mistake. But we have to behave differently from those animals, right? So what is behaving? What is evolving? What is being a good human being? Is to understand the purpose of life is to sustain life itself. Not only my life, your life, everybody's life, the flora and the fauna, the environment, I need to protect life. That is the purpose. To do that comfortably, to do that equitably, to do it to spread everywhere, we have all this science, technology, engineering, history, chemistry, whatever. The purpose of life is to sustain life. You feel very sad when you use technology and science to kill each other. And you feel proud of telling, I killed so many of them and they killed so many of us. Right? Sometimes using violence is inevitable, but never celebrate it. Do it because it is inevitable. That is very important. That I call it as a civilized human being, right? Who will not treat violence. Being non-violent is the most important lesson we all need to do, and then only we can claim that we are. So I keep telling last sentence is when there is not enough time to love, why are we finding time to hate? So the idea of whole education, knowledge, everything is to know how to spread love to everybody while we respect everybody for whatever they are. Thank you very much.
Thank you very much, sir, for taking us on a ride 10 years from now. It was indeed Really nice to listen to the stories which we had heard in our childhood, and now listening to them again with a different interpretation and the kind of extension to the stories that you have given. We are really in for a treat today, sir, and lucky to have an eminent personality like you as the chief guest for today. Thank you so much, sir, for your words of wisdom. May I now request Dr. J. Shivkumar, sir, and Dr. Krupa Rasne, ma'am, to present a memento to our chief guest, Dr. S.M. Shivprasad, sir. I now request Dr. Krupa Rasne, ma'am, convener INSEC, to present a memento to our guest of honor, Dr. Ramakrishnan Raman. Thank you, ma'am. I now request Dr. Krupa Rasne, ma'am, convener INSEC, to propose the vote of thanks.
A very good afternoon, I would say, because just 12 o'clock now. To one and all, respected dignitaries on the dais and off the dais, thank you is such a prayer that cannot be seen or touched. It must be felt by heart. I feel honored and privileged to propose this vote of thanks on this special occasion. To begin with, let me thank Dr. Chandraj Raichan, Chairman Jain Group of Institutions, Bengaluru, for the platform laid out by him. I feel honored to thank our today's chief guest, Dr. S.M. Shivprasad Sir, Director of Higher Education Academy, for his stimulating and timely remarks and for his gracious presence in the INSEC 2023 inaugural ceremony. Let me assure you, sir, I heard some of the words like thinkology for the first time, and it has really made me think. And if time permitted, I think we would go on listening to your speech. It was wonderful and eye-opening for us. Thank you, sir. He has award, no doubt he has got so many awards, as especially a CSIR end scientist would impress anybody. And sir, today I'm your time. I also thank Dr. Ramakrishna Raman sir for his story of how to ask questions, such an important thing for every student to understand. How to ask a good question is what a teacher is also looking for. Of course, as sir said, we are going to be an extinct species very soon with AI coming into picture. But I'm sure, sir, most of our faculty members will develop themselves and look towards technology as a tool rather than, getting their jobs out of place or whatever. Thank you, sir, for accepting, Raman, sir, for being a part of the successful international conference. A warm thank you and regards to Professor R.J. Dharwadkar, sir, Director, Jain Group of Institutions, Belagavi, for being the pillar of the institute. We do miss you, sir, today for the conference. I thank Sri Radhesham Heda, COO, North Karnataka Jain Group of Institutions, Belagavi, and Professor Uday Chandra, Director, JGI Group, for their constant support rendered in all possible manner to organize this conference. The success in hosting the conference depends on many people who are behind the scenes. I would like to thank our technical sponsor, IEEE Bangalore section, especially Dr. Alok Nath Day, Chair IEEE Bangalore section, for technically co-sponsoring the conference. I feel honored to have all the chief guests and speakers, and also Raman sir from IEEE Bangalore section with us today. I have worked under Raman sir's stalwartship earlier, and I have seen that IEEE Bangalore section has been growing to newer heights and is continuing to grow every year. In fact, yesterday we got a news that IEEE Bangalore section is one of the highest members all across the globe. We have reached the highest membership. I I request you, sir, and I hope to look forward as chair of North Karnataka subsection IEEE for your continued support and also guidance in also making our NKSS a good foundation and also our forthcoming international conference in Cape Town. We look forward to it. We are grateful to our principal and other principals across the institute, invited guests, delegates, and session chair, the session coordinators for both the physical and online sessions for taking time and attending today's event. Special thanks to the press and media for covering and giving wide publicity to the conference. Our sincere thanks goes to various committee heads, be it organizing chairs, technical program committee, advisory committee, the team of reviewers of the papers, whose members have shared valuable insights that have shaped the thinking of this conference. Warm appreciation to many people behind the scene, Harish sir and his team, who have worked hard to make this conference happen. I also thank our very dignified speakers. Ramakrishna Raman is there, Sunil Samya, and also we have our Chinese speaker who will be there online tomorrow. We thank all of them for accepting our invitation. We also thank all our session chairs, Dr. B.S. Halkariman sir, and we have Kuldeep Sambrekar sir for coming and attending our today's function as well. A big thank you to our Honorable Principal DJ Shivkumar and his vision for JCE to be a university as a resource of solution to diverse challenges of society by nurturing innovation, research, and entrepreneurship through value-based education. This conference is one such a step towards it. Under Sir's leadership, we hope to emerge stronger and become the best and preferred educational hub of the masses. Thank you, sir, for having faith in me as a convener of such a huge IEEE international conference again. Today, my words are not enough to express the gratitude to all the participants across the world, the VIPs of the conference who are attending and presenting papers in physical as well as the virtual mode. An event of this dimension cannot happen overnight. The wheels start rolling months in advance. We have been fortunate enough to be backed by a team of very motivated and dedicated faculty, students, committee, and volunteers. I cannot thank everyone enough for the involvement they have shown and the willingness they have expressed to take on the completion of tasks beyond their comfort zone. Once again, please join me in expressing my thanks to our lovely chief guest today and the guest of honor for taking time to be with us. Thank you, one and all. The morning session, the small announcement, morning sessions first, you will be getting your certificates post lunch and we will be having a photo session outside after this event. Thank you.
Thank you, ma'am. With this, we come to the end of the inaugural function, but I request all of you all to kindly rise for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मागे गाहे तव जय गाथा जन गण मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you, everyone. I request everyone to gather outside for a photo session. Soon after the photo session, we will having the keynote session by speaker.
see what happens. You'll see a lot of, I mean, what we call it, this is floating point numbers, 1.765 something, large numbers, all being multiplied and done some matrix multiplication transformations, and the output will be the force. Right? So essentially here what is happening is you have the data. So if you see here, conventional software, I had data, I feed it input data, fed to a program, gave me the output. That's conventional software, right? Always, here's a software program, what is the input? Then it takes the input, processes it, and gives the output. But here what did I do? I have the data, I have the output. I'm trying to figure out what the program is. Okay, essentially, that's what happens inside a neural. Right? I'm trying to figure out, let the network learn how the data is correlated to the output. Both of them is going to the output. But then it does its magic. Right? But it is not something that a human mind can understand. Right? If I go and show this to any one of you, will say, yeah, force is equal to mass and acceleration. If I show this program, I can't even figure out what's happening. Right? So this is inside what happens inside an AI. It's a neural network, the same thing. Right? When you look at a lot of things, there is some magic that happens. But then the challenge with this is it is not understandable. It is not explainable. So we are trying to look at using AI for complex systems, engineered systems that is going to have implications if it fails or if it does something wrong. You can't figure out what is going on. Right? Some of you may be testing software programs. How do I test this program? I have to feed in force, mass, mass acceleration, see if it computes force. That's how you test the program. If you give this program, I don't know how to test it. How do I say that this program is functioning good or not? So that's the major challenge. So that's where, so there is a lot of talk of AI. So AI is all about how do you interpret data, how do you learn from this data, how do you, adapt some of those that's happening in the data. So AI has been there for a lot many years, right? But then there are three things that happened over the last decade or so that kind of transformed. Right? So one is what is called the computation power. There is more computation power now than in the beginning networks were there even 5 decades, 10 decades back. But we didn't have the computational power to churn all those numbers. Right? So one is computational power. Right? The second one is availability of data. We have more data now than that was available maybe 2 decades back. And the third one is what is called democratization of resources. What it means is, if I want to start something on the AI, I don't need to invest in all the hardware and software. Right? I can get all of them on the cloud, which means the barrier to entry is much less. Right? I can always get what the resources I need from the cloud and then start doing it. For a startup, I don't need anything else than the PC with an internet access. Right? A laptop with internet access. I can access all those from the cloud. So democratization of resources, availability of data, computational power. This has in fact promoted the use of neural networks for solving a lot of these complex problems. So machine learning is all about how I can use these computational methods to learn from the data that is there, right, and figure out what is happening. So there are three types of machine learning. That's talked about: supervised, unsupervised, reinforcement learning. And actually, AI is becoming ubiquitous around us. We are kind of surrounded by AI, whether you are aware of it or not. There's a lot more AI now surrounding us than it was decades back. Right? So how can I build intelligence in the system? Right? How do I make a system intelligent with machine learning models? This is the kind of generic workflow that is there. Right? I need to take the data, right? I then need to train the network, and then I get something called an intelligent model, and deploy that onto a system, right? And make my system intelligent. That's how I have to use AI or machine models to do it. But then it's much more complex than that. Right? The key part here is the data that I have. Right? The intelligence that is there in the system is as good as the data that is used to train it. So it all depends on how good my data is. If the data is good, then my intelligence is good. If my data is bad, intelligence is bad. Right? So it is more like a garbage in, garbage out. Right? So it all depends on how good my data is. Right? So a lot of questions come. So when we're trying to make a system intelligent, what is the data that I have? What is the source of the data? Does it cover all the scenarios of the system? Right? That is planned to be used. So I see a lot of examples coming on paper. For example, the autonomous car that was driving. Right? the US was. It was mistaking the moon for the yellow light, and it was slowing down. Right? Why? Because the data that was used to train that never covered the scenario where a moon used to appear nearby the traffic light. Other example, more funny example, you are seeing the AI-driven camera to track the football in the match, to track where the ball is moving and moving. Right? It was tracking the head of the referee, who was bald and who was having this. So it was tracking the head of the referee. So you'll see all of them. While those data was not used, scenario was not used to train it. Right? So the intelligence we talk about, all in this AI and all of that is restricted to the data that is used to train it. So as engineers, we need to go under the hood. Right? We should not be like, hey, that's AI, and we get kind of enamored by it. It is more like go under the hood and see what is happening. Right? To see where does this intelligence come from. Right? So intelligence is only as good. So I can give examples of rifle being detected as a helicopter or things like that. A lot of these, and you can actually create what's called hallucination for this intelligence. Right? You can fool the AI system to think it is some other scenario than what it is actually. Right? You can actually fool an AI system if you know the data that is used to train it. Right? It's actually called as adversarial data. Right? You can actually fool the AI system by taking the adversarial scenarios and feed it and then getting what you want. You can kind of, so that's something that is also a hot research topic. There are a lot of new failure modes that are there when you start using AI system. Right? So let's say you're training an AI robot to clean the floor space of an office, and you give points for every dirty paper it takes and puts in. It may learn something totally different. Right? It may, just to gain points, it will first take all the papers, put it into the dustbin, then take the dustbin, throw papers all over the place, again go and put it, it will get more points. Right? It gets more reward points because all it is trained us to how to maximize its reward points. Right? So, but you don't know what behavior it is learning. Right? And if you try to go under the hood, you don't know what it has learned. Right? That's the challenge when you start looking at it. Another thing is the cost of making a robot. Right? So, for example, there was a case where they were using AI to look at the X-ray images or the scan images to figure out whether the person had disease or not. Right? It trained very well and it printed very well through. Right? But then that's what was the training data. Right? But then when it was deployed for the actual scenario, we will find it was giving a lot of wrong predictions. Right? By the way, the cost or the implications of saying that someone who does not have a disease, right, so saying he has a disease is again a problem because he's going to be fed and medicines that are not needed. Or if someone who has a disease, the AI says that there's no disease, he's going to miss the treatment window, right? So the implications are pretty strong. So in this case, what was found out was the training data that was used. Right? All the X-rays that were of people who had those disease had the doctors marking an arrow where the disease was. Right? So the AI kind of learned that whenever there was an arrow in the X-ray, that's when the person had a disease. But you don't know that. Right? When you look at the code or what it is doing, you are not aware that this is how it learned or this is what it learned. So that's why in research, there's a lot of research going on how do you make the AI more explainable. How can an AI come and say that this is why I'm thinking this person, this X-ray, this person has a disease because of that. Right? There's a lot of active research going on how do you kind of let the AI converse back in a human understandable way of why it is thinking so. Right? That is, again, a lot of challenge. So, with this brief introduction and the context of where we're looking at AI, I'll try to look at some examples of where we are looking at how AI can be used for some of the systems. So, my examples will be on engineered systems. Right? So, I will take some aircraft examples, UAV example, and then kind of show some scenarios of what it is. Any questions so far on AI or general? Any queries you have? So my technical point is yes, go underneath and see what is happening. Understand what is going behind the scenes, right, as engineers, right? And then see where the limitations of this technology are, and for you to start going into that. And of course, there is now the ChatGPT. If you go underneath of how it is being trained, right? it is all being trained what's called as self-supervised learning, right? So it takes a sentence, it hides part of the sentence, and then it tries to predict what the hidden words are. So all it's trying to predict is what is the sequence of words that follows one sequence of words, right? Like I said, hello, how are you? So like that, it is getting trained over a very large corpus of data, right? And there are a billion kind of parameters that are getting trained for it. It takes billions of dollars to train one GPT model or something like that. But then all it has done is just predict sequence of words. Right? If you go to ask ChatGPT, but in fact they are kind of improving. So 3 months back when I asked ChatGPT, right, I put this statement. Ramki lives in XYZ. XYZ is a hot place. Does Ramki live in a hot place? It said, I don't know because there's no place called XYZ. So I can't say that it's hot or not. A week back when I tried that, it said yes.
So, sir, if you have a physical by clear-cut equation, what is the need of the
Yeah, so we'll come to that. So when we are having physics-based equation,
they are already standard equations.
this is a standard equation. So one is that example was just to give a highlight of what goes underneath in a physical template. But we'll see cases where typically when you go to physics-based equations, they will assume a lot of quote-unquote ideal conditions. For example, for an aircraft, they will take it for point force. They will assume that the wind is uniform across the plate of aircraft. Or they will assume that the atmospheric conditions are standard atmospheric conditions. So when you get actual data, you'll find it slightly varying with what the physics predicts. So I'll see some shows an example. That's more of function. So that's where we're talking about how can these machine learning models augment physics based.
So instead of one equation, we can go for several equations. Till our model satisfies the requirement.
But then becomes very complex. Very difficult to model non-linear physics equations just by the equations part. You don't get that ability. That's why we look at data to do that because the conditions will be pretty different. We'll see one example. So we'll see some examples of that. Again, going back to ChatGPT, all it is learning. Right? For example, when I said it now, it said yes, XY is a hot place because now they're trained it to understand logic. Right? Fundamentals of logic in the physics and discrete math. Right? We'll start off with topologies and all of that. You'll see how like A to B and B to C, then A to C relationship is that valid or not. Right? Some cases it's not valid, some it's valid. So that all comes into those formal logic. So they all define that. And if you ask like, hey ChatGPT, what are your New Year goals? You'll see it giving an answer from this year onwards. I will go on exercise and do all of those things. But then that's none of ChatGPT's goals, right? It's because most of the training data it had those sequence of words following that. Right? So there is actually no person behind who's answering it, right? But it gives you a semblance of sentience. Right? It's as though somebody is answering it. Okay? That's why a major problem that's talked about is hallucination. It can give you an answer that looks as though an expert's answer is that. That's where I started mentioning. Right? Thinking is what is more needed. You have information for you to be able to discern what is right, what is wrong, match it with the fundamental understanding. Be aware that a system can do something wrong, and then use that to make your decision. So that's why. So quickly go on to some of the examples. So first, I'm trying to see one example of this. This is a case where we are trying to predict how much fuel an aircraft consumes. Okay. So let's take even a standard example like car. Right? You have something advertised saying that this car, the maker will give you 32 or 16 kilometers per liter of petrol. Right? Even if it gives that, that will be for a new car. Right? So let's say we buy two cars. I buy a car and you buy a car. You will see over after 1 or 2 or 3 years, it will be giving a different sense of mileage. Why? Because the way I drive the car, the conditions in which I drive the car is going to be different from the way you are driving the car. Right? So it's all subject to what's called different degradations, right? So different way the car is being used and all of that. So that matters. The fundamental mileage that is done is more physics driven, right? Of a fresh new car, but that is going to so. But let's say I'm trying to model and trying to predict. We have a lot of complex physics that goes into an aircraft. And we're trying to predict, model the fuel flow. We need first to collect the data. So as I said earlier, the intelligence is as good as the data that you used to train it. Right? So let's say I collect the data when the aircraft flies at 20,000 feet. And then I use it to predict what is the performance of the aircraft is flying at 40,000 feet. Would it be right? The whole physics and aerodynamics changes between 20,000 to 40,000 feet. Yeah, of course, because all of that. Right? So the first thing you have to do is, how do I get the data that is spanning all the scenarios and use cases where my system or model is going to be used. Right? So in this case, we collected data in terms of when the aircraft is flying from between 20,000 to 40,000 feet, at 20, 25, 30, 40, and all of that. Then similarly at different weights, at different atmospheric conditions, different speeds, all of that. So we have to collect tons of data over all of these scenarios before we're able to even say that, yeah, this AI model, this kind of experiencing some kind of reasonable intelligence. So we had to do all of that, and then we had to then go back and see whether the data matches the physics of our understanding. Right? That's where we'll have to look at, for example, a plot of temperature or of the max speed versus the altitude. And physics will say that flying at lower altitudes, at slower speeds, will consume more fuel than flying at higher altitudes and higher speeds. That's a physics, right? Then you have to go back and see, is your data matching the physics? If it doesn't match, either the data is wrong or the understanding of physics is wrong. So be open to question both, right, when you get the data. Right? And then you have to see. So now in complex systems, it is actually very difficult because you have multidimensional data. At most, we can visualize 3 dimensions of a human mind. Right? So one technique we have used here is what's called principal component analysis, where you try to, you can reduce, say, a 15-dimensional data to a 2-dimensional data and try to visualize what's happening through PCA. Right? So PCA is in fact used to build those lower models of higher order dimensions. So that again you can do some correlation and see. All this is to see if your data is good enough. Because the intelligence is as good as the data you use to train it from your model. Right? And then once I'm sure the data is good, then I feed in all of the data to the neural network. Uh, and then I have a model that is can predict what is the fuel flows. You can do try similar models for your car or a vehicle or anything that you do. Try to collect the data. I'm sure you have a lot of these neural network code is open source. Python you can do one if you're having MATLAB as an enterprise storage license, use that, or any other tool. Just try out and get your hands that you can figure out what is underneath the hood happening in AI. So AI is not going to be again restricted only to the AI specialist. Right? It's going to be transdisciplinary. You're going to have, you need to have, for example, circuit knowledge to apply AI for something. You need to have physics, aerodynamics knowledge to apply AI for physics. It's not going to be just some numbers with someone who is not having understanding of the numbers, what those numbers means to go on. For example, they may take a wrong data and give you a totally wrong intelligence. Right? So AI is going to be an essential skill for all engineers across all disciplines to start making their systems more intelligent. It skips all those graphs that cannot be used. We can look at the papers that are there. So this was again taking the flight data and trying to predict. So this was a case where we found different aircrafts exhibiting different fuel consumptions, though they are on the same model. For example, Maruti Alto advertised as 60 kilometers per liter. Right? But then if I take the aftermeasurement of 5 different Altos that are there, it's going to be different because of the recent conditions, all of that. Right? So how do they model this kind of stuff is where we can again use these machine learning models to get the data specific to each car, right? And then use that to augment the physics-driven predictions. So data-driven models that are going to be customized, right, for that. So when you talk about even like in medicine, right, can you give customized medicine and dosage for a specific person? Generally, when we go, we'll say, okay, throat infection, erythromycin or something like that. But then dosage is always standard, right? 500 mg 2 times a day. Now, we're not talking about customized medicine, customized dosages, along with that individual person's history and medical scenarios. We're talking about personalized medicine. So all of that is, then you need personalized data of that specific person, right? And how that person reacts to the medicine. So that you give them right quantity, not overdose, not. So this what we saw as an example of where I'm trying to predict the performance of a system. Right? In this case, trying to predict the fuel flow of a we'll now go to a more challenging thing where I want to predict the behavior of a system. Okay, this is again some of the papers we published where we try to use machine learning models also to adapt the behavior of a system. Here I've taken the example of a swarm of UAVs. And UAVs again is a lot of interest. A lot of colleges students and teams who are building these UAVs, drones, right, and trying to fly around these drones. Right. So one thing that is of interest is flying with a swarm of drones. We're trying to fly in a swarm. A lot of this, what's called swarm intelligence comes in. Again, it's not big from the natural systems. Like how do a swarm of bees fly? And things like that. So, how this, okay. So the swarm intelligence is where you are trying to give a mission objective to the swarm. Right? And then all of those individual entities have to work together to fulfill the objective of the swarm. Right? But then you're going to have all of these autonomous systems. It's more like a group of people coming together, right, to have an objective. But then the behavior is going to be totally different. Right? It's always easier to make one system do a specific function than a group of independent systems to come together. Like group of people come together, there is always a problem. Right? So you say like one person, there will be silence. 2%, there will be a conversation. Okay? 3%, there will be a gossip. 4% politics. That will typically come. Right? So here they are trying to design a set of independent systems, autonomous systems, who can take decisions on their own. Can we make them collaborate and come together and try to do something that is our mission? Yes.
Is it a master slave system or are everything masters?
Autonomous with limited control in terms of identifying like what is the mission objective will be done by say a leader, but then they can take turns. They can kind of take some of the decisions by themselves. There's also talk about fully autonomous can they recognize, but then still you need someone to say that hey collaborate like this. So in this case we had like one leader. I think that one of the spot be the leader telling others that this is the mission. So in this case, one of the mission thing what we look was the shape of the formation. Because that matters a lot when especially in different kind of scenarios, what is the shape in which you fly and how you are able to attack your target. So we have different shapes like flying in a triangle, flying in an inverted triangle, flying in a intermediate. All of those kind of different shapes are there, which will kind of help the swarm to achieve this. So in this case, what we call in systems term is what's called a system of systems, which means collaboration of multiple independent systems coming together for some kind of concept. So system of systems, you can see, for example, in IoT or IoT industrial of things. Right? Now it is more easier to connect systems to each other, to make systems talk to each other than it was, a decade back. So now we are all having, can my mobile phone talk to my car? From now I can find the status of my car that it is parked at my place at Bangalore. I can check the status of my car at my mobile phone. So now we are having all of these systems talking to each other. So that is where now we are having this concept of how can systems collaborate and talk to each other to get more functionality, much better behavior. So this is a case where we are having multiple systems talking to each other and kind of use some kind of machine learning models to understand the behavior of the system. So if you start looking at coming up to this, actually had more figures there. There's a simulation of it trying to kind of perform different maneuvers, the swarm of UAVs across different planes that is happening here. This was done in actually. We're trying to kind of simulate the system model and system behavior from what's happening. And then we will have different scenarios that will happen. Right? That's case called design of experiments or orthogonal arrays. If we have multiple scenarios, how do I test or how do I simulate different conditions? Actually, if you look at each of these 7 things, let's say 10 levels or 10 factors, each of them there are 2 or 3 combinations. Then there are so many combinations that can happen. But I cannot simulate all the scenarios. It will take a lot of time. if I take any two rows, the permanence combination would be tested here. So that's called an orthogonal array, where we try to, through minimal model protocol runs, we try to simulate all the permutation combinations that can happen in the system. So that is something again that's going to. So here, if you look at the system, right? Again, this is the graph. Right? We see what this plot is about. I'm having 6 UAVs. Right? So pairwise distances between 6 UAVs, I have 15 pairwise distances. Distance between UAV 1, 2, 2, 3, 1, 3, 2, 3, like that, right? I'm having 16 variables. Similarly, pairwise slopes along X, Y, and Y, Z, I have 30 slopes. But then for me to visualize these 45 dimensions, it's going to be really, really difficult. Right? I can only visualize 3 dimensions. But then here what I have done, what is done is those 15 variables are collapsed into a single variable on the x-axis, which is called the PCA of the distance, principal component of the distance. Similarly, 30 slopes are collapsed into a single value. Right? So now I'm able to visualize, to see here this a summary of 15 variables, this summary of 30 variables. What is the interaction? Those red lines are where the swarm is not good, the green lines are where swarm is good. So now I can visualize and say that, hey, there is this zone where this complex system is behaving good, there is this zone where this complex system is not behaving good. So then I will be able to easily analyze. Otherwise, I used to have 45 variables, very difficult for me to even visualize what is happening. So by doing this overall dimensions and mapping, we will be able to identify these kind of, understand what is happening inside a complex system where things are really complex. So in fact, we can also go and, okay, this is again a plot of how is the system behaving overall versus how the individual system is behaving. You can actually see in this green zone is where both one of the UAV 3 is good, and the system overall swarm is also good. Red is where both are bad, and here is where one individual system is good, but the overall system is bad. Right? Now they're trying to use machine learning models to do that. You can see the predictions coming very similar. The top left is your green, the bottom right is your red, and so you're now actually seeing machine model trying to predict or classify the behaviors, right? Similar to what you actually see as the truth data. So this is another example. We'll see one more example now of trying to predict the behavior. Now I can feed in all the state information of the swarm of UAVs, feed it to a neural network, and try to have the neural network learn when the behavior is good or bad. So again, here you can see the plots of, on the top is the truth data, when the actual system is good. You can see the machine learning model predicting almost similar. Closer to 0 means the system is not good. Closer to 1 means the system is good. Right? You can see how the machine learning model is kind of able to predict. In fact, this prediction happens ahead of time, which means before the system is going to go bad, you can have the machine learning model, the AI predicting that case something is going to go bad, which is again pretty difficult when you're trying to do a modeling by the physics. So that's again a scenario. So this is what I'm trying to predict. There's one more scenario where how can I make the system try to adapt its behavior. So again in a swarm, I taken this case of what's called a heterogeneous swarm, meaning swarms that are being designed independently, and then you want them to come together to collaborate. So how will the swarm adjust its behavior in tandem with what is the overall objective? So again, this was for what we have gone through, where the swarm tries to learn, right? In a swarm, the system goes into the swarm, it tries to understand what is good behavior and bad behavior. So there's something called reinforcement learning. Reinforcement learning is where you can actually train the machine learning model to learn, to interact with the environment and learn. Right? More like how, as children, we kind of interact with our ecosystem and trying to learn. For instance, as a child in a class, right? The teacher says, do this and don't do this. Right? Don't talk. the student still talks, what does this teacher does? He kind of say, appraise or scolds the student. Right? Student then learns that this behavior is not good. Similarly, can teach AI model or deep learning to say that you can reward the model to say that I'll give it plus 10 points when it's doing something, I'll give it minus 10 points when it's doing something else. So the system is able to interact with the ecosystem and then learn what is good and what is bad. Right? That's called reinforcement learning. So reinforcement learning, for example, is used for, let's say, to teach the robot how to walk. So what is the physics of walking? You see, if you're modeling a system with legs, right? There are joints, right, and then hip bone. So walking is all about what are the right amount of forces and torques I need to apply at the joints, so that you are able to the robot is able to walk. So now when you're trying to model that using physics, it becomes really really complex. Instead, you can put a reinforcement learning agent, right? And in a simulation world, ask it to learn what are all the forces to be applied in the various joints so that it's able to walk stably. So our what is called many learning or training episodes, you can actually teach the robot how to walk without actually programming it with all the physics-based equations. But it's trying to interact and learn. Right? So what you would do, you would reward it if the CG of the robot is so much meters above the ground. You will penalize it if the CG of the robot is near the ground, which means it is fallen. So with that, you'll be able to kind of let the robot learn by itself or getting rewarded for being able to walk and then trying to figure out how to walk. So that is very similar in a scenario here where actually the swamp is trying to do something here and then it gets onto a new system where it's getting penalized and then it learns the good behavior and then again it kind of relearns. So we have used this for swamp. As well as also we try to use this for case of a smart electricity grid. Smart microgrids is where you're having multiple non-conventional energy sources getting to the grid and then trying to see what has to happen so that the overall national grid is there. So that is another example of what we have seen. So we used to have what is called this intelligent agent, which is residing in each system, and then it used to adapt and learn how it needs to function within the overall. That was again a lot of this is at various stages of research and practical application. They are being kind of matured. So I would like to quote this. This is like a wiki page. It's actually for the system within body of knowledge. It talks about the systems thinking, applied systems approaches for multidisciplinary systems through. So that's actually a section on AI, which talks about when you're trying to develop intelligent systems, design intelligent systems, what all you need to be aware of. Right? What are the things you need to be cognizant of? How do you take care of the data? How do you ensure your data is representative of the intelligence that you're trying to use to train it? How do you validate if the system is good? How do you verify the system is good? How do you make sure the system is not taking a wrong decision that impacts the effectiveness of the system through? Right? How do you ensure that unintended consequences of the system? That is not again. So with that, I'd like to conclude saying that yes, there's a lot of scope of using AI for some of these modern complex engineered systems through, both to model the performance and the behavior of system. So a lot of these engineered systems are driven by physics, right? But then can use these AI models to augment some of these physics-driven models, right? Like we saw how the AI can be used to augment the physics-based swarm behavior with the data-driven to predict what the system is going to do. Plus the aircraft example that we saw. So all of these is where we are seeing application of AI for that. But then our fundamental engineering, science, and all of that is still needed, right? Because otherwise you will not know what the AI system is trying to do, or whether it's doing the right thing or not. That is the challenge with we as engineers, we need to be aware of what is going underneath the hood, be cognizant of that when you're trying to make it So to conclude, any queries, questions, comments?
Suppose we do research and kinds of injection findings.
Sorry.
Suppose we are doing something, we are getting some models.
Yeah.
And when these models are evolved, so there is a standardization process also. We apply for the more standards. And once they are standardized, then only it can be useful for the market.
Okay, so talk about standardization.
Here, what sort of standardization is going on?
So here,
The student come out with a drone, somebody will come out with a drone, and let's say they can harm also.
standard is not all.
Suppose student getting a drone, another person will develop a drone, another person will develop a drone, and finally it will harm the society.
Finally, it will.
Because harm the society. Because this thinking process is not controlled. There is no standard. Anybody can think anything and then develop a model. That's the case.
So it's not like, see, standards comes in typically when I'm talking about interfaces and interactions, and how they communicate with each other. For example, I'm going to use this protocol to communicate. Everything should have this standard interface.
Exactly.
That is where,
Like IEEE 802.3 or 802.11.
yeah.
What sort of standardization is going on this AI and
Okay, so there are standardization in terms of regulatory. Yeah. So if you look at, for example, even an aircraft or something, we have what is called as regulatory agencies. Like, for example, I can't go and design a CT scan machine and put it. I have to comply to certain regulations, and I should meet those standards and all of that. Same for aircraft. Why? Because those things go on will have harm to the public. Right? So that is where you are seeing AI is still far off in getting into those kind of safety critical systems. It is getting into mobile phones, all of that. So now the thought process, or in fact, one back, we had the European aircraft regulatory agency start releasing some kind of regulatory standards on what do they expect from those developers, designers, to show that they have followed the right uh, training and process to develop the intelligence. Right? So we're talking about what is called learning assurance. Typically, what we do in control system is called safety assurance. How do I ensure the safety of that? Now there's something called learning assurance. How do I assure that the training data that I've used to train the AI system is covering all the scenarios? How do I ensure that the AI is telling us what it is doing?
So like we have IEEE, ISO, and ITU. There are so many standard organizations. The standardized. So what are those organizations?
So there are all working groups that are coming up with those standards through, but then still we are far off. Our technology is not measured enough to put it in safety critical because we still don't know. So you will see AI more coming in non-safety critical things like in mobile phones, all of that. But then critical systems, it's yet to be developed.
My question is mainly, suppose you are giving a talk. So always you are giving a citation, reference. That is where it is existing. So that is one way of standardizing.
It is one way of communicating what is happening in the research right now. Standardized is where a lot of people come together and the technology is also measured. For example, we talk of technology readiness levels, TRL 1, 2, 3, 4, 5, up to 9. Right? TRL 6 level is where you go about a technology to see it has been done in a similar condition. Uh, so, for example, Wi-Fi usage on the plane is still not there. But then Wi-Fi is wrong. Why? Because probably it will interfere with the communication. It can cause loss of life. So, for you to look at any technology getting into systems, it will be the different categories of systems that are getting. So, technology AIML definitely has gone into banking, it has gone into stock market, it has gone into say all our natural language interactions, all of the things are getting through. But then it's not mature enough for me to put it to control an aircraft. It's not a mature for it to put it to controlling an industrial plant.
How to avoid disasters?
By not putting that, right now you cannot put it.
No, for example, drone. There are regulations. You cannot simply fly the drone
Yeah.
outside the campus.
So drone regulations that was, for instance, released last year.
But unfortunately, that varies from country to country. If you go for Indian institutions, they have separate regulations. For years, they have separate regulations. So my question: how to standardize so that everybody in the world they can get facilities.
See, there are two levels of standard that happen. One is country specific. You see, one is they'll have an overall general theme of interest regulations which everybody will comply with.
These are already sir available in India government.
But
For India government, these are already available.
yes,
But these rules are so strict, it's very difficult to think in this way. You cannot simply implement, you cannot develop a drone. The moment you start developing a drone, there are regulations. They'll stop you.
no. In fact, I see so many startups developing so many of those because of
The special permissions.
So there are a set of regulations, for example, based on which altitude you fly, what is the payload it can carry, what is the size of the drone, whether it is centered or not. So for me to fly at a below altitude, I don't need much permission.
That is from government side. But
Yes.
what about the standardization? What about the IEEE?
So there are the standards that you have to come up with. I mean, you have to comply with. Any of these things, there are certain things. How standards evolve when more and more practice is done, and then people come together and say that this is the standard that is done. Right? So IEEE or any of those organizations, they are coming up with standards. And then regulations will vary from country to country based on the ecosystem of that. Right? Autonomous cars, drivers, right? You can put them on in a US road, you put them, right?
Yes.
You have clear markings, you have more homogeneity of the vehicles, right? You have standard traffic lights, right? We put an autonomous system trying to learn what's happening in Indian roads, right? Indian roads, you see the driver in front, who will put the left indicator, show the right hand and go straight. What will the AI system kind of learn? Right? It will get confused.
Exactly, that was my question.
So you can't have those kind of regulations here. It all depends on the ecosystem management, where things are streamlined, where things are governed, right? So it is customized for each country. Interfaces, protocol standards are all common across, because that's how systems interoperate.
Only standardized, there is chance of misuse.
Misuse happens even otherwise. If you want to misuse, you will always misuse. Standardization is for the interoperability that you have to do, right? And to ensure. Regulation. So there are different between standards, regularization, and misuse. So that this is the regulation is different, standard is different, and use misuse.
I think to go ahead with this, it all depends on the human intelligence now. Whether I want disasters, I don't want disasters. Whether it's for the welfare of mankind or it's for the to use it otherwise.
Yes.
It's like a weapon we have. Any weapon now, say for example, if the soldier uses it, it's for the protection of the country, protection of our borders. But the same way the terrorists use it, it's for the, create disasters. So again, ultimately, it's the human intelligence which has to play a major role here.
Madam, we cannot depend upon human intelligence.
That's what you want the borders. You want us to develop the
Situations
borders.
like Russia, Ukraine, same thing will happen in every other country. Russia, Ukraine, the sea, there is no standard. There is no
standards.
So the human intelligence is working there.
See, standard cannot.
The thing is, UNO, no, United Nations is not, it has to be functional. But then again, we are saying the effect of why it's not functional and in what way.
I'm not telling that standardization will solve the problem, but certainly it will put a restriction. It will control at least before manufacturing, before applying the model.
Yes, that is regulation. Regulation comes with government regulation for safety critical systems. That is already there. So I can't take an AI now and put it on my laptop. I will not get permissions. That is regulation. Standardization is for interoperability, making sure things systems can talk to each other, standard protocol for communication, like that. Right? Regulation is definitely there for even drone usage, where scenarios safety critical, where I can fly, where I cannot fly. Everywhere there are regulations. Right? But regulations will not constrain research from happening. It will regulate the application of research for scenarios where safety or unintended consequences can occur. That much is there. So in fact, you can file a complaint if someone is for flying an unlicensed drone over a certain altitude. There will be radars that are monitoring it and they will come and say that. So those regulations are there. But from point of view of research, you can always research and do it. Application of research. Okay.
Thank you, sir. Way in which it showed how the models can be built for performance and behavior evaluation of complex engineering systems. complex field. Thank you so much, sir. I'm very and wish you your smooth day. I request Professor Sarma to present the moment of our Last time we had about 500. So this time let's see. So one.
Sir.
Madam, craft time anymore. ಅಲ್ಲ ಒಳಗೆ ಬರ್ಬೇಕಲ್ಲ ಸಲ್ಮಾ ಮೇಡಮ್ ಎಲ್ಲರಿಗೂ ಕರ್ಕೊಂಡು ಬರ್ತೀವಿ ಯಾರು ಹುಡುಗರಿಲ್ಲ ಎಲ್ಲರಿಗೂ
ಬನ್ನಿ ಅವ್ರ ಬರ್ತಾನೆ
The amount of time you give. She just introduced.
Good afternoon. It gives me immense pleasure. It gives me immense pleasure to introduce our next speaker to this August gathering. Dr. Sunil Soumya has completed his BTech degree in Computer Science Engineering and MTech in VTU Belagavi in the year 2014. He has completed his PhD from National Institute of Technology, Patna. Sir is presently working as assistant professor in the Department of Computer Science Engineering at Indian Institute of Information Technology, Dharwad. His areas of interest are applied machine learning, deep learning, information retrieval, and natural language processing. Sir has worked on e-commerce review ranking system, fake review detection, identifying hate and offensive contents in social media. Sir has, to his credits, 30 research papers published in reputed SCI index journals. Sir also has reviewed many SCI index journals such as IEEE Transactions, to name a few, multimedia, electronic commerce research and applications. So I hereby present to you Dr. Sunil Soumya. Welcome. Thank you so much, ma'am. Thank you. As a token of love and gratitude from our college. Okay, so first of all, thank you so much for inviting me here in this fourth international conference on emerging technologies. So I really appreciate that. And thank you for the nice introduction of me. I'll be talking about the combating hostile content in social media. It is one of the research area where I'm working. So my main area where I do the research is natural language processing. I have also worked on, as ma'am mentioned, that I have worked on the review ranking system of e-commerce website like Flipkart or Amazon. They have a lot of reviews, and we do often go through those reviews before selecting our product. We make our decision based on those reviews, right? So I have worked on that also, but recently I have also started working in the social media, especially in the hostile content detection. I will be talking about hostile contents. What are the kinds of the hostile contents we have, and what are the different ways people are approaching to identify this combating or to identify this hostile content. So these are the outline of my talk. And start with the social media itself, what are the advantages, disadvantages and all. And then we'll talk about the hostile topology. So what are the hostile? What is the meaning of hostile? What are the different terminology comes in the hostile? And I'll give you the dataset point of view. That through the dataset, how do we identify whether this particular text is a hostile or not? That is what I'll be focusing on. So dataset view, I'll just explain a little bit, and then
I'll talk about the various approaches of the machine learning, which people have used to identify this hostile content. Okay, and then we'll see what are the limitations and what are the future scope of this particular research area. Fine. So, yeah, as we know that social media nowadays it is anything and everything, right? So whether we are talking about the politics, we want to go to any restaurant, or we want to select any platform or educational platform to learn anything new. Now, everything we come to new through the social media itself nowadays. All the news, what we are coming, what we are knowing nowadays is through the social media itself. So we know the power of the social media. There is no doubt and there is no further discussion on that one. But by saying that, can I say that social media is controlling our mind, right? So we may agree on this point. Yes, social media is controlling our mind because in today, whatever you see on the social media, accordingly we make our decision also, right? For example, that fine that it's about the IPL, IPL itself or some movies itself or whatever it is. Okay, that whatever the social media says, okay, we are going to believe on that. We mostly believe on that. Okay, and we go with that. So sometimes it is hurting also, sometimes it is in your favor also, right? It can both the sides. So I can say that the social media is controlling our mind. We make our decision through the social media what we see in our day-to-day life. There is no doubt in that, right? But the point is, if we discuss that whether this social media is boon or bane, now, so then we can say that yes, social media is a boon as long as we are utilizing the social media in a positive context, right? As soon as it comes to the negative context, then it may no longer be the boon or advantage for all of us. Then it also has some other consequences, right? So according to that one, what we can see that social media contents can be divided into two types. The first type is positive contents, whatever we see on the social media, and all the positive things like communicating with someone who is very far from us, advertising, and many other things. All the positive things come in one part, and that we also known as the hope speech contents. Hope speech is the one which gives us the hope that okay, whatever you are doing, that we are going to appreciate that one. So that is called hope speech, and that comes from the positive contents what we have in the social media, right? The other side of the social media contents, what we have is this negative contents, and in this negative content, we have this fake content, right? This hate content, offensive content, and this defamation. All these are the negative side of the social media. And together, all these are known as hostile contents, right? So when we group all these negative contents together, we have termed it as hostile contents. Hostile contents are generally harmful. It is an inappropriate use of the offensive words, attempts to defame an individual, and posts that spread the disinformation. Let us understand this hostile content in more details, and these are some of the consequences of the hostile contents. That how exactly it can have the negative consequences. Like it can lead to the stress, it can lead to the depression, loneliness, negative feelings, loss of reality, and many more. In the worst case, it can even lead to the lives of someone. People do commit suicide. Sometimes it has been seen that just because of some posts, okay, which has been posted on social media, and he or she got harmed by them, right? So these are some of the consequences of the social media. Now, if we talked about this hostile content, as I talked, that these are the broad classification of the hostile content. We can have the fake, we can have the hate content, offensive, defamation, and these are some of the definition. You can say that. What is this fake content? A piece of information that is verifiably to be false. So any information, suppose someone is posting today any information on the social media, like for example, that Virat Kohli is not going to play the World Test Championship final, right? No, that may be the fake content, or it may be the true news also. We don't know that one. So as long as any news is not verifiably false, it is not a fake news, right? That is how we can identify the fake news. So to identify fake news, we should have some source which will authenticate that. Many times it comes from the government side also that whatever news has come that are all fake or something. Some post comes like that, and that makes all those news which were posted as a fake news. Then we can add the hate speech. So any post that targets a specific individuals or group of people based on their ethnicity, religious belief, geographical belongings, race, etc., then it comes into the hate speech, right? I'll give you the example so that you will understand it better. Then we have the offensive content also, where people do write some vulgar words, right, to harm or um, uh, to simply insult the individuals or group of individuals, right? And then we have the defamation. So how do we identify? We have some of the examples of these hate, fake, offensive. I have a list of them. Let me go through that one so that it will have better understanding of that. How do we identify whether it is a hate or fake or something? For example, these are the hate data sample which we have collected from the social media. For example, first one, look at here. That this is called as God bless them to hell with the blacks. Now, if we read this text, this is a hate text. Why it is a hate text? Because hate speech, this particular message, it is a hate speech against a target group because of their skin color, right? So this is one of the properties or one of the, you can say that, way through which you can identify whether this particular text is a hate speech or not. Now see, we want to develop a machine learning algorithm or machine learning models. Models has to understand that okay, in this text, what is the word which makes that sentence hate or which makes that sentence fake or defamation or anything else. So for that one, first of all, we should understand what sentence is a hate, which one is like defamation, which one is offensive, and that's why I've given you this example so that we can understand that one first of all, right? Then we'll see that which models are good for that and what are the models people have used for that, right? For example, second one, Islam is a false religion. However, unlike some other false religions, it is crude and appeals to crude people such as Arabs. So some sentence is written about the Islam. Again, this is a hate sentence. Why? Because it is attacking the group composed of Arab people based on their origin, right? So it is a hate. And the third one, although it is talking about some national socialism, it is not a hate because this is a general sentence and not harming, not hurting any group or individuals, right? So this is how we can identify whenever a particular sentence has some word which is directly hurting some individual, some group of individuals based on their religion, based on their reason, based on their gender or something, then we can say that this is a hate speech. Similarly, fake news, these are some of the examples of the fake news, right? For example, all hotels, restaurants, clubs, etc. will be closed till 15th October 2020. Now, this particular message was posted on Facebook, and this was a fake news. It came during the Corona COVID-19, right? And it was a fake news. So, but when it was posted, then it was not known to the people whether this is a fake or not fake. Now, it was verified. Okay, it was verified maybe by the government, okay, or by the Facebook itself, right? That this news which is posted is a fake news. So fake news, unless it is not verifiably false, someone has not claimed it that it is a false. Till that time we cannot say that that particular text is a fake or not fake. Okay, so the complexity of finding the fake news is higher than finding the hate content or offensive content and all. And there are some other examples also. Similarly, if we come to the offensive content, it is also one of the part of the hostile content. Let me read this sentence. Grateful Trump doesn't have a dog in the White House. He's a cruel man. So it is an insult of an individual. So whenever there is some kind of the insulting sort of thing, then it is a offensive content. That when we say that it is a hate, but in hate also it is a kind of offensive, right? Or people are using some vulgar words, some abusive word, right? Cyberbullying sort of things. Then again, it comes in the offensive, right? So we have some other examples also. And moreover, nowadays what is happening that the text which is coming on the social media, it is not only falling in one of the category. It may fall in more than one category. Like the first sentence what you are seeing is like नरेंद्र मोदी चंद्रयान #नरेंद्र मोदी चंद्रयान मिशन सक्सेस होने के साथ ही मोदी जी ने वहां जाकर what is that डिस्टर्ब कर दिया था, जिसके कारण वैज्ञानिकों के महीनों की मेहनत बेकार or something it was by that was a news which has come. So this particular sentence comes in these three levels: defamation, hate, and offensive. All three categories. So what happens nowadays that whatever sentence which comes in the social media, it may fall in more than one category of this hostile content, right? Similarly, we have some other examples also. So why I have shown you all these things is, first of all, how the data should look like whenever suppose you are working in this area, right? Because we have enormous amount of data in the social media, right? You know that one. And people are free to write everything. There is no restriction on anyone. Fine. Then sometimes it is very like sometimes people may write these negative contents also in the form of fake, in the form of hate, offensive, and all of us are seeing that one. That for example, that yesterday itself that there was a news from last 2 days. It has started that new Sansad Bhavan in New Delhi has to be inaugurated, and then there are a lot of discussions, and many things are going on the social media, right? Some of the contents may be hate also, right? So what I mean to say that as a researcher, as a computer scientist, we don't have to go into that one. But what we have to see is whenever a text which is coming on the social media, and if it has some negative meaning, we should restrict that content as soon as possible so that it will not spread. Okay, it will not spread to the other people, to the other region, and people will not make their own decision. People will not start judging that one and make their own decision based on those contents if it is negative. So that is what is the main target. And how do we do that? So this hostile identification research has these three components, these four components we can say that. First one is this gold standard data sets. That means that you should have the data, first of all, right? In the form of any of the data sets which we have seen in the previous slides. The fake data, the hate data, offensive, or the multi-class data also. Then we have to treat these problems as a classification problem. If your data is labeled, then we can easily go with the classification problem. And in the classification problem also, we can have the single task learning or single task problem and multitask problem. In the single task problem, whatever model we are going to develop, machine learning model we are going to develop, that is going to tell you only one class data. For example, if we are going to feed a text to the machine learning model can tell you whether it is fake or not fake, but it will not tell you whether it is hate or not hate. Why? Because my model is trained only for fake or not fake, right? This is called single task problem or single task models. But the situation is we are having multi-class data that at a time a text can fall in more than one class. Like it can be fake also, it can be hate also, it can be defamation also. In those scenarios, we can have this multitask problems or multitask models where at a time we can identify more than one class. For example, whether a particular text is fake as well as hate as well as offensive or one of them or two of them or whatever it is. It is called multitask learning problem, right? So that is what we have to identify based on the data set what we are going to get. Okay, and then hostile. Other than this classification approach, we can also have some intensity-based approach. For example, there are some hate which are not very intensive. Okay, right, but there are some other hate messages which are very intensive. For example, people have directly blamed someone, right? Or they can say that in some of the posts, we are not directly hurting someone, or we are hurting also to some extent. On the range of 1 to 10, the hate category we can say 1 or 2, but in some other text it can be 9 or 10. So then how do we identify the intensity of the text? So that is also the way of identifying the hostile intensity, right? And people have identified the hate intensity, which can be low, medium, or high. People have also identified the offensive content intensity or curbing the hostile intensity. Curbing in the sense, suppose I have written some hostile content or the offensive content. Now, if I am from the Facebook and I have to show that message to the rest of the world, what I will do is I will change the word. Okay, whatever word I have used in my sentence, I am going to change that word to some nearest synonyms so that that synonym is not going to hurt someone. Okay, the meaning, overall meaning may not be changed completely, but that more intensive word, right? Those words will be replaced by some other words, right? Now that is known as the curbing the hostile intensity. And people have also approached like hostile categories correlation. That what is the correlation between hate and offensive, fake and hate. So these are some of the ways or the some of the ways in which the research in this hostile identifications are going on, right? All right. So now let me just tell you some of the gold standard data set. If you are interested, you can also use these data set. These are publicly available data set, right? So these are the some of the papers, Patwa et al., then Jampiri et al. So, for example, the first paper, they have released the COVID-19 fake news data set, and this is a binary classification data set, fake or not fake, right? Similarly, the second paper, they have come up with the offensive language identification, and this is also the binary classification data set. Similarly, the other two also. And some other data set also, you can explore these things, okay, if you are really interested in doing this, the work in this particular area. Now, after this gold standard data set, let me talk about little bit about this, what are the models people have used for identifying the hostile content. For example, the first paper, what you can see here, it talked about the hostile messages. How do we identify the hostile messages in a whole? It is not differentiated like what is fake, what is hate, or what is offensive, right? Like together it has identified whether it is a hostile or not, right? So then, what are the features it has used? It has used the content feature like noun phrase or imperative sentences, and it used the decision tree for hostile message identification. Similarly, in the second paper, what we are seeing, there the authors have used the unigrams model and type page and support vector machine to identify whether a post is a resist or non-resist post. And these are the recent posts. Most of the work in the hostile content has been done after 2015 itself, and other than the fake news detection, right? So then in the third one, you can see that one that people, this author have used the embeddings, word embeddings, and they have used the model long short-term memory (LSTM), which is the RNN-based model, and then they have identified the target, which is a raciest and sexiest, right? Then the last one is again the model, this Tran et al. They have used the word model. Nowadays, this word is very famous, right? Most of you must be knowing that one, and all these like ChatGPT and all. Now they are all related to this word. That word has come after the transformer, attention, or we need, right? So they are all related with all. So word is quite famous nowadays. We have many variants of the word nowadays available. So they have used this one to identify hate and non-hate. And all these works have been done on the hostile text detection in English, right? Now, why I am pointing this one? Because this slide, I have shown the hostile text detection in low resource languages. Now, what is this low resource languages? English is a high resource languages because in all over the world, people are speaking English. So it's a global language. You know that, right? So all the models, whenever we develop, first of all, we try for the English itself. Right? What is this low resource language? If we talk about the Kannada, it's a low resource language which is being spoken only in this particular region of India, or any other language like Hindi, which is only spoken in India, not any other part of the globe, right? So they are all the low resource languages. So all the models what we have seen in the previous slide, they are good with the English language. But when it comes to the low resource language like Kannada or English, Hindi English, Kannada English, Tamil English, then these models suffers. Okay, they don't know how to understand those texts. It it is very difficult for the machine to understand those texts because people often mix the Hindi, English, Kannada, English, Tamil, English. So we are very habitual in mixing the text on the social media, right? But there are some papers which have come, for example, the first one, they have used word and character and gram, right? And they have used the SVM, night base and random forest for abusive and hate speech detection. So overall, if we see that how the research in this hostile identification has gone so far, that first of all, people online social media content. First of all, we have to collect the data from the online social media content, whether we want to work in the fake or hate or whatever language, whatever target we have. So we have to collect the data. Then we have to do the feature extraction. Okay, and in the feature extraction, these are the types of the feature people have extracted. For example, the handcrafted features like TF-IDF feature, count vectorizer, because every time the text data has to be converted into some form of numbers, right? Because machine understand only numbers, they cannot understand the language what we speak, right? So this TF-IDF count vectorizer is one of the form through which we can feed the data to the machines. These are all the handcrafted features, but these handcrafted features lost the contextual information. Okay, they don't preserve the contextual information, that how the words are coming together, they form some meaning, right? But this handcrafted feature, they don't preserve that meaning. So we came up with this embeddings. And there are two types of embeddings, like static embedding and dynamic embedding. And this word, Excel and Elmo, which are quite famous nowadays, they comes in the dynamic context embedding. So what happens whenever we have a text, we convert it into its corresponding embeddings using these Word, Excellent or Elmo, and that corresponding embedding we feed to one of these models. So here we have the classification models. Like in the ML models, people have tried with logistic regression, support vector machine, KNN, random forest, etc. But what it has been seen, because we are having now millions of data, an enormous amount of data, this machine learning model, or rather I will say, conventional machine learning models are not good. Okay, when your data is growing in millions, right? So this deep learning models or neural network models are good in those scenarios where the people have used this feed forward neural network, recurrent neural network, LSTM, YLSTM, and many others also. And but nowadays, this transfer learning is quite famous. We don't have to develop the model by ourselves. We can utilize these models, and these models are already trained on millions of data. So what we have to do, we have to collect our data. We have to feed in one of these transfer learning models. We have to get the output. Only thing, at the output layer, we have to do some fine tuning. That how many classes we are required. Accordingly, we can do some tuning and we can get the output. So these are the overall approach what the people have gone through and people are using nowadays. Right? In fact, this chat GPT also, it has been used, initially it was released for generative text, that you ask something, it is going to generate a text, fine, and then it will give you that paragraph, that code or whatever you will ask. But then at the same time, it is also being used nowadays for classification purpose. So you do one thing, you go to the chat GPT, you give one text, okay, and you ask whether the text is hate, fake, give the classes, whatever you want, then it will give you the percentage. Okay, that okay, hate 90%, fake 10%, hostile 30%, whatever. So classification also it is doing like very effectively. I have seen that one. So that is also people are using it for those classification as a classification model also. So what are the limitations in the existing literature? That most of the work, whatever, whether it is a chat GPT or Word or any other models, most of the work are done on the high resource language. High resource language in the sense English. But when it comes to the low resource language, and in the country where we live, in India, most of the language are low resource language only. Then these like Kannada, Tamil, Malayalam, Maithili, right, or any other language also, these ChatGPT may not work with. Okay, so there we have to put our own approach. Okay, so then we have to develop our own model. We can use ChatGPT also, but we have to do the fine tuning that how the ChatGPT is going to work with the Tamil language, Tamil text, right? So that is the limitation which we have to see next. Single task. hostile predictions. So most of the tasks which has been identified by the researcher till now is a single task. But the multitask learning, people have started looking into that one, but still a lot of work has to be done in the multitask learning. Future direction, if we talked about, the future direction is all about this code mixed and it's script mixed. If we are in the context of India, okay, I'm talking in the context of India, the future direction is in the context of this code mixed and script mixed text, right? I'm not going to write everything in the chat GPT in the English. I can write, I am good, aap kaise hain? Right? So now this is a script mixed. There are two scripts which I have clubbed together and then I'm feeding it to the chat GPT and then I'm asking something from the chat GPT. Chat GPT may not understand if it is not trained for the Hindi or Devanagari script. Right? Similarly, we have n number of scripts available, n number of languages available, right? So we have to think that how we can develop a model which will understand Hindi, English together, Hindi, Kannada together, or English, Kannada together. Now those things are lagging in the existing system, and this can be the future direction of the in this particular domain. Along with that, we can also club this NLP or the text content with the photo or image, or you can say that meme, right? For example, look at here. So now this meme, this particular meme can also fall into one of the classes like text, hate or not hate, right? But the approach what we have gone through so far for the text will not work here, okay? Because here in this particular meme, we have image also, we have text also. Okay, so now the model has to understand multi-modality, what we say, right? So that how do we feed these two things together? Maybe we have to do some OCR, right? And we have to extract the text from this image. We can feed text, we can feed image, we can club those features together, and then we can do the final predictions. But those things, people have done this some work on this one, right? But you can look into that one. And one more thing, which has come in this ACL conference in 2022, that in this particular meme, if we have to identify that who is the hero, who is the villain, and then who is the others, so how do we categorize that? How do we categorize? So these works are also very limited. Only in this particular conference, this data set was released. We don't have enough data set also in this one. But then easily we can, because we have data. Nowadays, we don't have data only in the form of text. People are clubbing everything together, right? So this is also one of the future direction where you can look into, and data set is easily available. Or you can also identify the intensity based on these target, whether a particular text belongs to religion, it belongs to any organization, or it belongs to any individual, then we can give the intensity of the hate. If it is belongs to any religion, then the intensity is very high. If it is belonging to any organization, the intensity is in the middle. In individual, it may be at the lower level. So in this way also we can look into the future, we can develop the data set and we can do the predictions. And finally, we can also see the correlation. Correlation in the sense, suppose we have one news which is posted and that news is a fake news. Okay. For example, people during the Corona time, people have started posting that if you will drink this particular, say that, then you will be cured with the Corona, right? We were like a lack of knowledge, or it was coming in the social media, right? That many people have believed that one. They started following that one, and then it led to their life also. So there is a relation, not only in the Corona time. One more example, if I give you, you will understand it. That people have started saying that China has this COVID-19 is a biological weapon which was released by the China. Now, due to this particular sentence, what happened? The anti Asian, right? The other countries like Europe, UK, US, what they started hating the Asian countries. Why they started saying that, oh, okay, this Corona of the Asian And then here is my conclusion. So what we the good thing about the social media, all of us know that, and it has to be there. We cannot simply delete that one. No, I don't need the social media just because it is showing a lot of propaganda, a lot of negative news, and no, that is not the solution, right? So we cannot deny what is good about the social media, but at the same time, we have to understand what is the consequences of the dark side of the social media, and how do we identify those dark side. So obviously, we can make some law. There is no problem that okay, if someone is posting some hate news, then this is the law. Then they can go to the prison or whatever it is. But that is not going to be effective. We have millions of views and millions of text, right? So there should be some AI approach, machine learning approach, and that's what we have talked about. That how to deal with this hostile content through the machine learning approach. We have seen the limitation and the future scope. And hopefully, if you are interested in this NLP or this hate news detection, this will give you some knowledge that okay, how do we start, right? And you will get the data set also easily, right? And then you can start your journey from here. These are some of the references from where I have built this slide. Thank you. So, from the audience. Yes. Correct, correct.
But I think like a single group depends on, for example, if someone has a this year, they will have conservative, they will have something. Where there is no ground truth of what a classification. How is that handled? Especially like someone considers this as conveyors and how to say this is classification.
So in those cases, sir, we usually go with the voting approach. Right, so it is not only one person who has labeled a particular text. Suppose you are saying it is hate. I will say no, it is not hate. Because it will differ from me to you, right? Depends that which context that post has come. But then in those cases, what we do, we go with the crowd. Okay, we do the voting. So instead of labeling it only by one person, we ask, say that number of people to label, say that 5 or 10, and then we take the voting approach accordingly. We do the democratic approach, whatever you say. We go with that, and that is the actual truth or the ground truth for that particular text. In those cases where there is a confusion, right? Yeah, it may be biased.
Occupied by the people, set of people who are voting.
Right.
So if it's a media that is surrounded by one view, others views gets wrong.
That is true. So definitely it will be biased. Okay, but then whenever we label, then we also keep in mind that that group of people, they should not be from the same religion, right? That could be one of the problem in the biasness. They should not be from the same location or something like that. So we keep that in mind, but we cannot ignore the biasness. That I agree with you. We cannot completely ignore the biasness. That is there in the system. Any other question?
Any other questions? Has given us good information about how do we recognize the content which is predominantly becoming more and more obvious, especially these days. We saw it during the elections, we might see it again, witness it in the coming 2024 elections, which has already started. And otherwise also there are so many news which look so authentic and which look so real. And that's the, what to say, there's a power of content creation. So this has its own effects. I mean, effects are the like it can be for the good, it can be for the worse. Like morning session, we saw like one of the participants was asking sir about how do we have rules and regulations, or how do we control like the model that we create for the behavior analysis and other things. So, such a situation, I mean, these things are going to happen for our social content as well, social media content as well. And ultimately, it's humans, we need to be responsible for what we talk, what we think, and what we spread. But to create models for that, I don't know, maybe it could come in the near future as well, because what we thought was not possible some just a decade or 2 decades back, or 5 years back, it has already become a reality. The same thing goes with the moods now also. We started with just 1 or 2 transistors on a chip, and now we have billions of transistors, which was thought that it was impossible. Actually. So the same thing happened. I think similar things should happen here, and hopefully someone will come out with maybe uh, the research scholars or some of you might come up with those kind of models which will help us to come out with the models or come out with research ideas which will spread goodwill in the society, which is the basic need of the art. Hopefully it should be possible. Let's hope for that. And I thank Professor Sonia wholeheartedly on behalf of it's an honor to be here. And I request Sonia sir to accept our program. The certificate is inside. So right now our childhood we used to have those topics for our debates, whether science and technology is boon or bane for the mankind. That debate is going to be there, sir, for any of the inventions. Just the other day, I read in ChatGPT the inventor person. He has expressed his concerns about the way it's going to be used, and he wants the government and the regulatory associations at the helm of affairs to come up with strategies to ban it or to use it in a the rightful method. But I mean, the inventor has his own views about how detrimental it can be for the mankind. Yes, sir. Just the other last week, sir. He expressed his views.
Search packet is search packet is
Go ahead.
Yeah. I'll turn it off.